Hi everyone, I'm Ethan Lee, a bioengineering grad student in Manu Prakash's lab at Stanford, where I've been involved in developing various open source scientific instruments and medical device prototypes, mostly around the hardware-software interface. These days, I work on software for the PlanktoScope, a low-cost and open source motorized microscope designed to image and count plankton in water samples. For this talk, I'll discuss some problems which I experienced as I started using and then contributing to the PlanktoScope project's software, and how I'm solving those problems as the project's current software maintainer. Part of why I like building software, even though the world has too much of it, is that when we're designing a hardware system to do something complicated or interesting, often the most practical and flexible approach is to embed a computer into the system in order to run software which provides part of the functionality. Software also enables us to iterate quickly so that we can gradually make improvements to share with users as updates for them to install. But many of us know people, or maybe we are one of those people, who avoided installing software updates on their computer out of a very real fear that those updates could break their customizations to the computer, for example, some software they installed to control some scientific equipment. When users feel like they have to choose between receiving software improvements from other people versus keeping their own modifications intact, this reflects a contradiction between the values we might want our open source software and hardware projects to have versus what practical processes and tools are available to us as users and developers running or developing these projects. I encountered the same contradiction in late 2022 when I first started trying to use and modify the PlanktoScope software. The PlanktoScope embeds a Raspberry Pi to run a PlanktoScope-specific operating system, the PlanktoScope OS, which is based on the Raspberry Pi OS. The PlanktoScope OS integrates several programs which control the hardware and provide a web browser-based graphical user interface, together with various OS configurations and system services, for example, to make the Raspberry Pi easy to access through a web browser on its Wi-Fi hotspot. The PlanktoScope OS was built through a complicated, entirely manual process, and it's updated by reflashing the Raspberry Pi's SD card with a new version of the entire OS, including updated browser apps and OS configuration files. This is because it would be tricky for an update script to correctly edit every single file in the OS from the older version to the updated version when the user has also edited arbitrary files in the OS. The simplest robust approach is just to delete all the user's customizations as part of the upgrade. So if you need to add a bunch of modifications and extensions over the standard PlanktoScope SD card images, then you have to perfectly record every single thing you changed, because if you want to integrate any future software updates from the project, then you'll have to redo all your changes over the new PlanktoScope SD card image, which includes those updates, and this requires manually merging your changes to certain files with the PlanktoScope project's changes to those same files, and you have to do this for every single update. This is in fact what I would have had to do with the PlanktoScopes in another research project I'm working on, which tries to use a rack of 10 machines as building blocks for a larger networked system. So the analogy of open source tools as building blocks, while reasonable here if we froze the PlanktoScope code forever, doesn't capture the practical reality of how the project would be customized as a system which changes over time. Because I needed to maintain and evolve my customizations to my machines, keeping software customizations specific to my work while trying to combine them with future changes from the PlanktoScope project would have been a lot of tedious, error-prone work. This is illustrated by another project in the PlanktoScope community, the LacaScope, which tried to modify and improve the PlanktoScope software. But both the PlanktoScope project and the LacaScope fork didn't have enough resources to coordinate on the changes being made, and as a result, the two projects have diverged in a way that makes it very hard to directly share source code improvements from one repository to the other. This is because, although the PlanktoScope software is modular and easy to reconfigure and modify and recombine as a static snapshot of files from a single point in time, the way the project had integrated its various software modules was not enabling members of our community to share software modifications and extensions in a way that would be practical for other people to recombine with their own changes iteratively over time. To solve this problem with how the PlanktoScope project integrates its software modules, I've incrementally taken all the config files provided by the PlanktoScope OS, which we need to change often, or which may need to be customized or replaced, and I've split them up into packages which are hosted online in Git repositories, and which can be deployed onto any Linux computer using a tool I've been building called Forklift. With Forklift, I can then make a specially structured Git repository called a palette, with a set of specification files which collectively declare the use of certain package repositories at particular versions, and which also declare packages to deploy from those repositories when Forklift applies a palette by updating a computer's OS, including its config files and apps, to match the palette's specifications. I'm currently working on enabling palettes to also declare that they'll import particular specification files from particular versions of other palettes. This way, it's simple to define a palette which combines everything from several other palettes and package repositories, and also adds its own customizations, such as replacing a package with a modified version from some other repository. This system of package repositories and layered palettes gives us the foundations for an open App Store system, which will provide to help users install or build their own PlanktoScope-specific software add-ons. This could also be useful for retrofitting an add-on system onto other Linux-based hardware projects. Forklift packages can provide apps by specifying Docker containers to be deployed on the OS. Docker containers are a useful way to make individual apps simpler to combine and deploy by isolating each app in various ways. When Forklift applies a pallet to the OS, it deletes, creates, and updates all the Docker containers on the OS to match what's declared by the pallet. I've already added a few programs from other open source projects and integrated them into the PlanktoScope to make it easier to use and troubleshoot the software, and I'm in the process of migrating the PlanktoScope's other software into Docker containers so that they can also become replaceable apps. When applying a pallet, Forklift not only updates the computer's Docker containers, but also copies various files from package deployments of the applied pallet into a particular export directory. Starting with the next release of the PlanktoScope OS, a step early in the operating system's boot up process will overlay files from that directory over the base OS's files before the files need to be used. So now we can change all relevant operating system files and all Docker apps on the PlanktoScope just by switching to a different pallet or to a newer or older release of the same pallet and then rebooting. And since the user of each PlanktoScope can set and change which pallet they want to apply to their device, or even make a custom pallet for their device, this provides a way for users to specify their customizations and make them easy to reuse across devices and easy to reuse and integrate across different sets of customizations. To give a demo of Forklift, I've connected my laptop to a PlanktoScope through the PlanktoScope's Wi-Fi hotspot. Here you see the PlanktoScope's graphical dashboard. And so when we press buttons in the dashboard, it sends commands over MQTT to a Python program running on the PlanktoScope, which controls the hardware. So what I'll do for this demo is I'll connect this YO terminal, which is basically just an LCD screen with a USB port and other stuff we don't care about here. And I'll connect it to the PlanktoScope. Right now, this PlanktoScope is running the standard PlanktoScope OS palette, so it does not know what to do with this device. And what I'll do is I'll deploy a custom palette that I've made, which basically adds a Forklift package to deploy a Docker container, which has a simple Python script that just listens to all messages over MQTT and prints them out to this YO terminal. So to do this, I'm going to enter a command in the terminal here. And this is basically just preparing the palette to be applied on the next time the Raspberry Pi boots up. So now I will reboot the Raspberry Pi. And now we see that the PlanktoScope has booted up and the Python program started up and sent some messages over MQTT, and now they are being printed out to the YO terminal. So if we go back to our graphical dashboard, and so now as we start running the pump, we see some messages about the pump being started. If we stop the pump, then we see more messages here. So now the add-on the software add-on has basically added support for this hardware module that I've added. And we can also very easily switch back to the standard palette. Let's see. And so now when I restart, this will get cleared when the power cycles, and then the PlanktoScope will reboot, and no messages will be printed out. Okay, and so the PlanktoScope has rebooted. We'll reconnect to the dashboard. And so now when I press the buttons to start and stop the pump, you see that no messages are being printed out. So this shows just how easily we can try out new software changes, but also switch back to an older version that was working for us if we run into problems. If you relate to the kinds of problems I've described today, but Forklift sounds too complex with things you don't need and too simple for things you do need, here are a few other projects which might be a better fit for your use case. Either way, if my work on Forklift and the PlanktoScope OS sounds interesting or potentially useful to your open hardware project, please reach out to me. Right now, Forklift is still an experimental prototype, so a lot of documentation hasn't been written yet, but I'd love to help you try it out. Thanks, and I hope to hear from you online or in person.